Many companies today use a VPN connection to allow workers to securely connect to their corporate network. So this tutorial is designed to explain basically how a VPN works. Even in the early days of computers, organizations wanted to send data from one place to the other. One example might have been you might have a very large university that has a mainframe computer. So we'll look at this university, and perhaps there's another university in the city some distance away, and it just has a terminal. It can't afford a mainframe, but it wants to be able to send information to the mainframe to be executed and then get the output back. Well, the only way these were physically connected together was through the telephone system. So people used to use what were called leased lines. If you wanted any type of connection which was guaranteed, you could have used the basic phone system where you dialed up, but that wasn't quite as good as having sort of a dedicated line. So in the early days, connecting two organizations or a remote user that wanted to be sort of permanently connected to an organization that was separated by geography was done through leased lines. Now, one of the problems with this was the expense. So one type of leased line which two organizations could connect together was something called a T1 line, and T1 had a rate of about 1.544 megabits per second. Not much by today's standards, but a line like that locally might have cost you $300 a month. And if you were trying to connect organizations from, say, one side of the United States to another using a T1 line, yeah, you could pay up a whopping $8,000 a month. So the lease line concept was good for the telcos, but was pretty expensive for organizations. So what happened is a new technology evolved called virtual private networking. And virtual private networking was a way to securely connect one organization in one area to another remote area, and do it in a secure fashion. That was the whole purpose behind virtual private networks. Now, leased lines had that security built in. It was a dedicated line from one place to the other, so it was difficult for someone else to sort of tap into that. Well, there are two technologies that really made VPNs possible, which we'll look at. And one was the availability of some type of network, broadband network, that was available to the public at a cheap cost. And this was the development of the internet. The second was a bunch of standards that could be used by various manufacturers so that different equipment could work together to produce this VPN connection. So if you look at the diagram here, a virtual private network connection is designed to connect one organization in one remote area to another, but it's using this public network in between because the public network is cheap and it's reliable. The logical equivalent, what we want here, is this is going to work just like a leased line where you have an organization here, and it's just as if it's hardwired to the remote location. Now, if we look at the types of VPNs that are available, there's two types. This is called a remote access. Really, they're pretty well the same thing. And remote access means I have a remote user, and it is going to use the public internet to attach into a corporate network. There's a firewall here, and that user is going to authenticate to the company network through the network server and be able to access any of the resources in the network here, files, printers, or whatever. A site-to-site is where we have an organization that's remote, and it has its own section of this corporate network, which is serviced by what's called an extranet server. And this is, again, using the public internet, coming in, authenticating to the network, and is more or less the resources are controlled by this extranet server, but it still has resource availability to all the resources inside the corporate network here. Now, what are the components of a VPN network? Well, there's three parts to setting up a VPN, and we'll briefly talk about them. The first is authentication. The second is tunneling. And the third part is encryption. These are three parts a VPN needs to construct from end to end. The first one we'll talk about is the tunnel. So I have a network over here, and a user in this network wants to access some resources over here. So let's suppose there are some resources called Fred and Barney. These are server names maybe. So when packets are constructed on this network, the users just want to indicate where they need to go to. Well, I got a packet that I want to send to Fred, and I've got some data in here. I can't send that out into the internet because the internet doesn't know these names, Fred, Barney. These are private, what are called private addresses, private to this network over here. So what we need to do is set up metaphorically what is called a tunnel, some way where I can send these private packages through the internet and direct them into this network. So we use encapsulation, and all encapsulation means is that I'm going to take that packet and I'm going to put it inside a larger packet with some headers, and the addressing is going to use what my public internet network here is going to accept. So I've encapsulated it. I've used the public network to transmit that packet over to a VPN server, which will accept the packet, which will unwrap it and send that packet back into the private network and deliver it to Fred, whatever server here was named Fred. So that idea of encapsulating what are called private protocols or addresses, wrapping them up using the public internet to send them to another network is called tunneling, and there's various protocols to do that. Now, authentication, whenever I want to set up a VPN connection between one network and another, there needs to be a way where you can identify and authenticate who you are. Am I who I say I am? Because this VPN connection only wants to allow connections to members of its organization. So it makes a request through the whole system of setting up a VPN. A request is made. The VPN server will say, who are you? Okay, I'm Jack, and this will say what's your password. A password or some type of authentication mechanism will come back, and it'll say, okay, I know you're who you say you are, and so I'm going to continue to set up the VPN connection. So again, there are many protocols, many ways or methods that I can use to authenticate. Now the third part of this is encryption, because even when these packets go out and even when they're in the tunnel, it's possible for those packets to be viewed by anyone sort of with some sniffing software out here on the internet. So we want to encrypt. And there are many, again, many standards and encryption protocols. AES is probably one of the highest one, and you can use 128-bit encryption or 256. You could use something called DES or triple DES, and so there are a number of different protocols that you can use to encrypt your packets. But these three things are necessary to set up a VPN connection. So you have a tunnel which is delivering the packets from one end to the other. Authentication is allowing the end user, the end VPN server to verify you're who you say you are, and encryption makes sure that if anyone in the public network is viewing your packets, they'll just see garbled information. It's all encrypted and they won't be able to get it. So that's what a VPN is. In the basic form of a VPN, it's using a private network, it's using a public network to make an end-to-end connection between 2 points in a secure fashion. So we're going to look at an example of how a VPN gets set up. So we have a remote user here. They have a network card and they have an ISP. And the ISP is using a 192.168.0 network here. And if this remote user, which only has one network card, we're going to send a packet to apple.com, it would simply send the packet normally out through the network card and through the internet and to apple.com and backwards. So it would just use the normal network card. But now the remote user wants to attach to the corporate network over here using a VPN connection. Now there's many parts to how this all has to be set up. Well, we have a VPN server here, and VPN's server is going to use a bunch of different protocols that it can support. And three of the major protocols that it could use is one by Microsoft called point-to-point tunneling protocol. It could use something called IPsec, I think sec for security. And IPsec is really a framework which allows you to use a bunch of different protocols. You get to select which authentication protocol you wish to use. You get to select which tunneling protocol you wish to use, and you get to select which encryption you wish to use. Another protocol which is popular is called the Layer 2 tunneling protocol, and it was really responsible for setting up a tunnel, but allows you to use any encryption and authentication you wish to use. And often the Layer 2 tunneling protocol is used with IPsec, and IPsec does selects an encryption protocol and an authentication protocol to use. So sometimes you'll see L2 tunneling protocol used in conjunction with IPsec. But regardless, your VPN server has to use one of these protocols and within, or one of these systems, and within one of these systems like IPsec, you have to make sure that both ends are using the same components inside the protocol suite. So sometimes it can be difficult, even though there are standards, it still can be difficult to get all this set up properly. The point-to-point tunneling protocol by Microsoft has sort of standard defaults, and it's easier to get working with clients. However, it is less secure, and so most security analysts don't tend to use point-to-point tunneling protocol. But if you don't have high security requirements, point-to-point tunneling protocol is built into all of Microsoft servers, and it's easier to use. So in all operating systems today, whether it's Linux or OS X or Windows, there are VPN clients built in. And so I can set up, and we'll show in a later tutorial, how to set up a VPN client. And when we go to set up a VPN client, we first have to specify this network, which requests a VPN connection being made, and that's handled through this VPN server. So one of the first things that happens here is the authentication phase. As a client, I'm making a request to set up a VPN connection to this company, and the company is going to ask for a username and password. I set that up and send that information, and then the VPN server is going to send me back an IP address. And what gets set up, so now I've authenticated, it's going to go ahead and set up the VPN connection, and it's giving me an address that's in this corporate network. And so what happens is, on this computer I set up actually a second, which is called a virtual NIC. I only have one physical NIC, but now I have a virtual connection, so it's like I have two network cards here. So what happens is, if I have an application and this application says I want to send a packet to this network, then the operating system takes that packet and it does all the VPN stuff to it. It encrypts it, it sends it out using, and encapsulates it and sends it out using a tunnel, and it gets taken to the VPN server, which unwraps it and sends that packet into this local network. Now logically, it's just like I have this type of connection. So we can think of anything that's going to this IP address as simply going through this little connection directly to the VPN server here. Now, there's something you should be aware of with VPNs. Whenever you set up a VPN, sometimes once you set up a VPN, anything is going to use the VPN connection. So what that means is that if I'm sending a packet to apple.com, it's going to use the VPN. Basically, it's going to come in here, it's going to say, apple.com, okay, I know that's not local, so I'm going to send it back out. So that can chew up bandwidth here. Also, if you're a person who maybe works for two different organizations and you set up a VPN to organization number one, you've got to remember that all your traffic's going through organization one. So if there's any monitoring traffic here or any firewalls here, they could interfere with the packets being sent, or they could even be monitoring your traffic. So be aware that can happen. Now probably the best scenario is that this computer should, basically, if I'm sending something to apple.com, really I don't want to use the VPN even though it's set up, so I should just send that packet out this way to the public network through the normal fashion. But packets which are designed for the 172.16.21 network would go through the VPN. If your computer is capable of sort of differentiating that and sending those in two different ways, that's called split tunneling. And usually you can configure your VPN to split tunnel so that any traffic that's not designated for this private network is not going to be encrypted, wrapped up, and sent to this VPN server. So that's briefly how a VPN works in any computer system, whether it's OS 10 or Windows or Linux. It's all going to work this way.